welcome to our latest installment of our online learning series. Today we're going to be welding doing a weld using a rolling 250 and one of our data number 6. My name is Sergio Arellano, and
my name is Sergio Yipin, and I'm the International Service Manager for McElroy. As Sergio says, we're going to be showing you a procedure how to do a proper test with this rolling 250 that we have behind us. Sergio will start setting up the data loader and setting up the pipe on the machine itself. Okay, and then I will come back and keep doing the fusion. All right. This will be a housekeeping. So if you guys have any questions through the webinar, please just write them down on the chat, and we will answer the questions at the end of the session. Okay. So I will leave you started now, and you can start doing the process on the machine.
Okay, everyone. So first thing to do, we're going to set up the pipe in the machine. We're going to face the pipe, and then we're going to check that it's properly clamped, and we're going to check the alignment in it. Today we have a 125 mil pipe, 6 mil of thickness. We are going to leave the machine off temporarily to improve the audio in the webinar. Normally we would have the machine on continuously, but just to try to improve the audio, we're going to keep it off until we have to use the hydraulics in it. For this pipe, I'm going to leave about 40 mil of pipe outside the machine to be able to face off about 1 inch or 2 centimeters of pipe. We do want to be able to leave some pipe sticking out to be able to face it, but we don't want to leave too much because it will take too long and it will leave a lot of shavings in the machine here. To look for the specific amount of pipe to leave in your machine, you can go to our reference section in the manual on page 14, and you can look at those distances. What you want to be looking at is F and F1 in that table, or give us a call. For larger pipe, you want to leave more. Larger pipe and machines, you want to leave a little bit more distance in the pipe. This is the distance that we're talking about. In this case, we are leaving 40 mil. So say for this size, let's say for this size of the machine, leave about 40 mil. Okay, so as you know, our machines have four jaws. We're going to go ahead and adjust this jaws. Normally, you want to adjust the outer jaws a little bit tighter to make sure that pipe is not going to slip. And we want to use the inner jaws to adjust our high low. They will be tight but not so tight to allow a little bit of adjustment. Keep in mind that we want to align for our high-low alignment. We want to tighten the high side up. If we have one side of the pipe that looks a bit higher, we're going to tighten that side up to align all our high-low adjustments. So outer jaws will be a bit tighter, and the inner jaws just kind of tight and to allow a little bit of adjustment. In larger hydraulic machines, this is all done with hydraulic fans, so we don't have to worry about this. we want to make sure we clean the pipe before facing it. By cleaning the pipe before facing it, we make sure that there is no dirt or residue in the pipe that can contaminate the face of the pipe once it's faced. So we want to clean the pipe with lint-free from cotton rags or lint-free paper. So this pipe is pretty clean, but we just want to make sure we do that every single time. Now I'm going to go ahead and start facing the pipe. We're going to check the high low first, and then we're going to face the pipe. If we face the pipe and we have to do a high-low adjustment, after facing the pipe, we need to do the high-low adjustment and then face the pipe again. I'm going to turn on the machine, so you might see a little bit of more noise. So, safety advice. Before we turn on the machine, every time we're going to handle the machine or we're going to move away from the machine, we want to make sure in our manifold block, our directional valve is in neutral. That means carriage is not going to move, and it's heating, so it should be moving. So this carriage to move, you would have to go to fusion and overflow. So for this carriage to move, you would have to activate two levers. So for safety reasons, when we turn on the machine, we want to make sure these two are in neutral and heating, just to make sure it's not going to move. So to take the pipe, we are going to put the machine in the facing position. Yeah? And we want to use very little pressure. So we will turn the pressure down and start increasing it until the machine starts going. Face it. Facing. Until our carriage starts moving. Starts coming down. So I shouldn't have to put too much pressure on the carriage. It's better if we do this process without too much force on the carriage. As you can notice, the spacer has two stops. We want to make sure we face the pipe all the way to the stop every single time. When we reach the stops, we will let the spacer go around a couple more times, and then we stop the spacer. As you can see, we've reached the stop here. So I'm letting you go around a couple of times. Now I'm going to stop the spacer. And I'm going to come back to you. Yeah? When I'm going to work on the machine, I go back to heating and neutral. Yeah? Okay, we want to clean the pipe using lint-free cloth. We want to make sure we get rid of any impurities, any possible impurities on the face of the pipe. that could go in the face of the pipe. Yep. Now that we fix the pipe, we want to go back and check our pipe load. Yep. Pipe load looks very good. If we had to do some adjustment here, we would need to reface the pipe. So I'm going to turn off the machine temporarily just for audio purposes. Normally we would leave the machine on. Now as you know, we've faced the pipe. We've made sure our high low is good. And now I'm going to show you how to set up our data loader. One more thing that we want to do right now is do a bump test. We're going to bump the pipe at full pressure just to make sure it's not slipping in the jaws. And then we're going to set up the data logger. I'll turn off the machine again while doing the data logger just for audio purposes. That's it. Yeah. To do a bump test, we do a mark on the machine, which I have already done, just to hit the pipe at full pressure, make sure it's not slipping. Yeah. So, as I said, every time you're working on the machine, or you turn on or off the machine, we want these to stay in neutral and keep. Yeah. Also, right now we're going to start setting up our data logger. Whenever we're not working on the pipe, we want to make sure the pipe is nice and closed to avoid any impurities from going into the pipe. If there's wind in location, or if there's any possibilities of going in the face of the pipe, we avoid that by leaving the pipe closed. So pipe that's closed, did a bump test, high low is good, so I'm going to start setting up my data load. So, for that I will start the joints. And we have different options here that we can, normally on the first joint in the day, we will have to set up all these. On subsequent welds, these will all be already populated, and the only thing that will change will be things like joint ID, joint number, stuff like that. But we'll go through all of these. Process pipe. We are going to do fusion. You could also do a pressure test if you want. You're going to pressure test your pipe. You can also measure that and record that with the data loader. So in this case, pipe fusion. Joint ID number one is good. Job, whatever your job is, operator. You can set, in this case, Sergio Gidry will be the operator, will be doing the fusion, but you can have all of these already set up. You can have your ID number, your certification number, any information that you need, and it's already set up. Okay? In this case, all you need to do is tap on the operator, and that's it. The machine, same for the machine. You can add different types of machines, but in this case, we have a rolling 250. Rolling 250. Of course, if you want to add a different machine that's not already set up, of course you can do that. But this one is already set up. I'll show you what information is in it. When you set up a new machine, you just look up a machine model and that will populate size of the hydraulic cylinder. So this information is very important because that's how the data logger will calculate the pressure that it needs to use during the fusion process. Yeah? All right. So our machine is already set up. Rolling 250 to tap on it. There's other options if you're going to do an in kit. So if you're going to do a weld in trench, you would have hydraulic hoses running from here to the carriage, or if it's going to be a tie-in. So it's all this information you could select. If you want extra information about the welding machine, you can look up in the operator manual. You click on operator manual, you can browse through the whole manual. Yeah, if you want to look up specific information for that machine. Yeah. So the original first page is already set up. Well name. So if you enable extended job details in settings, you can add in more information about the weld, like procedure name or variation name. Say if you are welding an elbow or a T or a valve, all of that information you can put in this section. Extended job information, or if some area of your project, you can put all that in. Or you can choose to have this section off. This is extra information, it's not critical for the weld. Fusion type. There's different types of fusion fusions that you could do. Sidewall, you could take, it branches from the side of the pipe. Miter fusions, which are tilted. Dual container would make, which are two pipes, one inside the other. This is a simple butt fusion. And that welding standard. We can use any standard from GBS, WIS, ASTM, but in this case, we will use ISO 21307 single pipe interfacial pressure. A good idea is to quality control. Pictures are a very good way to help in your quality control. So a good thing to do is take pictures of your welding process. One thing to do is take a picture of the pipe before the weld happens. So a good thing to do would be to take a picture of the high load. I will do that just now. Yeah. So that picture will be part of our weld report. Yeah. Now we can type in any weather conditions, ambient temperature, pipe temperature, weather condition, types of shelter. There's options like none, outdoors, tent. Many people use the tent as a shelter. In this case, we're indoors, so I will choose that. As I said, all of this information can be typed in just for the first weld. All the other welds will be or populate. So our pipe is 125 mil. Here in this section, you can type SDR or thickness. In this case, we will type in 6 mil of wall thickness. So very thin pipe. Yeah. Pipe material P100. Use the identical pipe. Both pieces of pipe are identical. And this will tell you what your interfacial pressures will be according to your standard. So, Sergio Gibran will show you this is where you have to measure your drag in the machine. Sergio Gibran will go over that with you, and he'll continue with the welding process.
Okay, guys, so now I'm going to show you how to actually measure drag on our machine. So the first thing we're going to do is we're going to make sure we got our levers neutral here and heating. Okay, and then we're just going to turn on the machine, and we're going to separate the pipe about 50 millimeters. Okay, so we can simulate the moment at which the pipes are going to be soaking against the heater. Okay, so that's why we separate them about 50 mil. And then what we're going to do next is we're going to basically put the machine on closing and heat on the selector valve, and we are going to start increasing the pressure if necessary in order to see the pipe moving closely. If the pipe doesn't move, then we need to start increasing that pressure. Okay? So let's start the machine. I'm going to try to speed up a little bit more so you can hear me well. So let's turn this on. Now I'm going to open the carriage about 50 millimeters apart. So about that will be a good size. So now we're just going to put it on heating, and then now that we are on heating here, okay, we're going to close that carriage. Okay, so let's put this all the way up, close it, and if you start moving, then that's going to be my drag, and I'm going to measure drag here on my dump level. Okay, so I'm going to close it. So the pipe is moving, and I'm going to get measured drag. So as you can see, my drag that the machine is actually recording at this point is 2 bar. Okay. Now, if you have 6 meters of pipe on this side, or 12 meters of pipe on this side, or a longer section of pipe, your drag obviously is going to be higher. Okay, because you require more pressure in order to move that pipe forward. So what we want to do is measure that drag every time we do a fusion. Okay, it's not the same drag every time. So that's why you need to measure it every time you do a fusion. Okay, so now we have our drag. Now we can calculate the pressures or the fusion pressures that we require for infusion. So we click next. And now that number is showing me, my pressure for the standard that we are currently using, which is the IC2107 high. Okay, so as you can see, you got your 5.89 bar, which is your beat up, and your fusion pool pressure, and your heat stroke, which is the same as the drag pressure. All right. So in here, we're going to start by pressing the selector valve down to fusion, leave the machine on closing. As you can see, my current pressure, I can just, by moving the fusion pressure reducing valve, we can modify the pressure that we're applying on the pipe face. Okay? So as you can see, my current pressure is 4 bar. Well, we need to be around 5.89 bar. So I'm just going to increase that a little bit. Okay, that should be fine. You don't need to be exactly on the same pressure because you have 12 tolerance there. Okay, but that should be fine. Now we click next. And now my data loader is asking me to measure the temperature on the heater itself. So that's something that I'm going to do now, and it's something that you need to do every time you do a fusion as well. You need to make sure you measure the temperature on your heater. Okay, so I'm going to grab my thermometer here, and I'm going to link my heater. And I'm going to measure the temperature on both sides of the heater. Now, on your data loader, you can see that he's asking me for two measurements on each side. Now, we can put one measurement or we can put 4 measurements on each side. It depends on how many measurements you want from your heater. So we can just double check here. We go to 13 Celsius degrees, okay, and we measure here, we go to 16 Celsius degrees, okay, and you just check all around to make sure it's all good, and it's all good on this side, okay. Now on this side, we go and we check again. So we go to 17, to 16, to 13, to 15, to 17. Okay? Just make sure the surface of your gun, if you're using a laser gun, just make sure that surface there is parallel against the surface of the heater. Do not measure with an angle because you can get an incorrect reading. Okay? Just a tip there. Okay, and now we come back to our data loader. And we can click, so we're going to click on each of the measurements here, the green dot. Click there, now the dot is yellow. Now we are able to reproduce that temperature. So 213, 1, and probably 217 on the other one, which is some of the readings that I got. Now I'm going to click the heater. Clicking that button, and I'm going to introduce the readings that I got. As well, the readings were pretty similar. So I'm just going to put 213 on one and 217 on the other. Now, if you are measuring temperatures on maybe a truck or a machine where the phaser is exposed to the ambient temperature to the wind, you might see a difference of temperature on each of the sides. So, but as long as you are within the range that is specified for your standard, and in this case, our standard is telling us that we should be between 200 to 230 Celsius degrees. Okay, so as long as we are within that range, then we are fine. Okay, that's why we always aim to be around 215 to have a bit of a room there of tolerance or error. Okay. Okay, so now we're going to get next. And now my data loader is telling me all the information to be prepared for starting that fusion. And so as you can see, it's telling me that my heat pressure should be 5.89, which is my fusion pressure or heat pressure, the one that we set up on the lower valve there. We got 1 milliliter. So that 1 milliliter that I showed you next to me is telling you what it's telling you about the initial melt that you need to get on your pipe when you put the pipes against the heater. And so once you bring the pipes against the heater, you want to make sure that you get 1 milliliter of feed all around the pipe on both sides. Why do we want to do that? Because that's going to tell us the heater. Okay, the pipe is in full contact with the heater. So that's why we want to make sure we get that 1 milliliter of water on the pipe. Doesn't matter if you get a bit, thicker bead on top and a thinner bead on the bottom. Just at least you want to get 1 millimeter minimum on the whole pipe. Okay. It's also telling us about the heat soak and about the heat soak time. It should be around 1 minute and 6 seconds. Okay, so that's pretty quick. And also it's telling us about the heat bead after the heat soak. So after you finish your heat soak time, then you should be able, you need to measure the feed size. That's going to be formed between the heater and the pipe, okay? Because that's another condition that you need to make. And it's a way of certifying that your heat soak was done correct. Okay? So we'll do that. We'll check that we have a hex heat of about 2 millimeters that we can compare with our heat. We can introduce in there and convert it. Okay? It's also telling us about the freezing and cool time, which is about 2 minutes and 24 seconds, and our opening and close time, which is about 6 seconds. Okay? Okay, so now what I'm going to do, now that we know all this information, okay, I'm going to open the carriage, all right, and I'm going to put my heater inside. Just open the carriage enough so you can allow the stripper bars on my heater, okay, to be, on top of your jaw. Because these stripper bars are key for removing the heater once you finish the heat soak process, okay? But if you don't have this on your heater, when the heater is like that, like this style, then you please add them because it's important to guarantee a good jump. Okay, good quality jump. Okay, so I'm gonna open the carriage now. I'm gonna be okay, so my selector valve should be on fusion, and I'm gonna open the carriage. So about that is enough. Okay. Now I'm gonna bring my heater and I'm gonna put it inside the carriage. But first, before I put it in, just make sure you clean it. So, grab a bit of wrap. Okay? And just make sure you clean it on both sides. Please remember to use proper safety gear so you don't get burned. Right? Now I'm ready to put this in. Okay, so as you can see, my stripper bars are just a little bit off the edge. Alright? This is what you really want. So now you can basically start your fusion process. You can start on the data lover. Then just wait, like 5 seconds or so, and you can start closing down your machine. Okay? Just wait maybe 5 seconds. And then you can just close the carriage. Okay, now you can see how the pressure goes up, and now you are in the field process. Now it's very important to pay a lot of attention here because you want to see that 1 millimeter of feed. And once you see that 1 millimeter of feed over the pipe, you can utilize, the light. You can check that out. Then you basically move your selector valve to hit. Okay? Wait until the pressure goes down to drag. And then you move your valve here to neutral. And now you can set your timer here. Okay? And now you're going to start counting your heat soak time. Which is about 1 minute and 6 seconds. Okay? So once you reach that time, then you need to verify the feed size, okay, which is about 2 feet. So now I have this, okay, so I have my next key here, and I had my hex gauge in hold like this. That's a crystal. And now you can introduce it in there, okay? Just to compare that beat size. Just to make sure you got the 2 mil, okay? From about 45 seconds, let's just wait until we get to 1 minute and 6. And we can compare them with our hex speed, that beat size. Okay, so after that, then I'm going to be able, if I need the 2 conditions, then I'm going to be able to remove that heater, okay? And then I can do my dilution. Okay? While you remove your heater, you need to inspect the faces of the pipe to make sure there is no contamination there, and then you have a parallel front face between the pipes. Okay. All right. So we are 1 minute and 23. We can now compare inside. All right. So I compare, and it's all good. So now I'm going to basically put my selector valve on fusion. Okay. I'm going to open this and I'm going to let the Jones tool open remove the heater. There, we're neutral. Move my heater quickly. It goes and it's back. It's all done. Now I put my heater in back. Reset my timer. Okay, I'm going to wait for the fusion and cool, which is about 2 minutes. 34 seconds. Okay? So as you can see there, with some of the camera, we are not done that fusion already. Okay? And now we're just waiting for the cooling time to get done. And so we can inspect the whole process. Okay? Obviously here in the last color you can see the beat up, the beginning, then you can see how it went down. To release that pressure from beat up to heat soak, and then you can see, the whole time it took me to actually heat that pipe, and the time it took me to actually remove the heater from the fusion zone. Okay? And once this is done, we can actually see the color aids that color provides, which are really helpful for operators because you are going to be able to actually inspect that joint and with a jackal. You're going to be able to inspect the joint and make sure that you did the right procedure. Okay? That's really critical for your operation. Okay? You will let you catch any issue while you were welding. So we've got 1 minute and 33 seconds. There's still 1 minute to go. Once we reach that time, the next step is basically put your selector valve in heat just to reduce the pressure. Third, first you click on the left alert, so you stop recording any pressure measurements or anything because you don't really want to catch that. And then after you click on, you can take pictures of the zone, etc. And then you put your selector valve in neutral and your selector valve in medium and your carriage valve in neutral position. Okay? Alright, so we're about 2 minutes and 20 seconds. So after the 2 minutes and 34 seconds, you can actually wait a couple of extra seconds. Maybe 5 seconds more or something like that. Just to get a little longer of the cooling time. Okay, we're about 2:38. So that should be fine. Okay. So now I'm going to click go. Now that elevator is asking me if this joint is complete, so I'm going to say yes. I can put notes, any notes you want to add into your report. Okay, this joint can be amended. So just make sure you put correct information there. Okay, so they're going to stay there forever. You can add notes in the future if you do not erase any notes that was taken. Okay. So we can add like to actually put the machine in neutral and turn the machine off and take the pipe out of the machine and actually take a picture of my final product. Okay, I'm just going to put it in neutral, put it in mini. Okay, and now I'm just going to open the jug. Release the pressure here. Okay, and I'm going to open my carriage. Okay, I'm going to open the carriage a little bit because if not, then my pressure is going to hit my inner jaw of the big size of the carriage. Okay, I'm just going to open the carriage a little bit. Once the patient clears the jaw, then you can just put it back in neutral, open the jaw, and turn on my machine. And now we have our product in here, okay? And so I can take a picture of that joint if I want to. Okay, so I'm just gonna click picture. You're gonna see a bit of a movement there. I'm just gonna like that. And now you can take a picture of your joint. Keep going. You can be closer, you can take more pictures if you want to. Then you can take a picture sideways if you want. Keep going. Okay. You know, you can take as many pictures as you want. Alright. Now I'm going to click next. And now here on the joint report is where you're going to see all the information, okay, about your joint. So you can check, you know, your details and, you know, any notes, weather conditions, the fusion machine you use, pipe specifications, the pressures that you actually use, the fusion type, you know, specification parameters, heater temperature to tube, the GPS location are also recorder, okay? The time, you know, that it took you to do the fusion time. So it took us about 5 minutes and 55 seconds to actually do this joint. Okay, so from the moment we start joint, and you know, that's a longer old when it was loaded. So it's actually telling me that this joint has been already loaded into the mold, which is our cloud system, which we already covered in one of our webinars. If you want to check this out, please go to our YouTube channel and check the webinar for a mold. Okay. Okay, so the device information is telling you information about your data. Okay. So now we click next. Sorry. Let me show you the front end. So I'll show you this part of the graph. So here you see the front end plot of your joint. Okay, so you can see your heat up. You can see the green bar, which basically is telling you the tolerance, okay, from 0 bar or 0 pressure or no pressure to your drag on top, okay, which is gonna be here about, you know, the drag that we mentioned was about 2 bar. Now, and then the length of that bar represents the, you know, the total amount of heat soak time that you actually require to heat that pipe. Okay, so you can see we heat that pipe a little bit longer than what we needed, but that's fine. Okay, as long as you don't leave it for too long, then that should be fine, right? And obviously the yellow line represents the, you know, the pressure measurement. Okay. Now you can also inspect the opening and close time, so as you can see, you know, as long as the yellow line is within that red bar, okay, then it should be fine. Okay, that red bar is basically telling you the 6 seconds that we had to actually open the heater. Okay, so now I did it within time, so that's good. And then you got your summary plot, which is actually showing you the whole process. Okay, so a few tips here, so you can see my pressure was closer to the bottom of the of the tolerance of the blue bar. You want to be always in the middle range, that's good. But as long as you are within that blue bar, then it should be fine. And obviously the length of that blue bar represents the whole fusion and cooling time that it is required to actually complete the fusion with a good quality. Okay? So as you can see at the beginning of the report, there is a little line there. That's the 5 seconds that we want to see. So because if we don't leave those 5 seconds, we immediately do the beta, then the person who is reading this report wouldn't know, for how long you actually did the beta. And so it's critical to know, how long it took you to do the beta. And also the 5 seconds after the blue bar are good to actually see that you complete the cooling time, accordingly to the standard that we're in. Okay? And then if you see the photos, you can see all the photos that you took during the whole process. Okay? Alright. So that's basically it, and that information should be now uploaded into my cloud segment. Okay? Alright. So you guys have any questions there? Very good. Any questions there?
No questions so far. Let's see if we can, no, we don't have any questions in the chat.
Okay. All right. Well, if you don't have any questions, we basically, finish this webinar. Okay. For those of you that go late into the webinar, we are gonna probably be uploading the webinar. We're gonna be probably uploading the webinar, in a couple of weeks into our YouTube channel. Okay. And so, so you can read, just go again about, through the process and make sure you understand how this join was. Okay.
Or write us an email or give us a call if you have any questions about today's session. Thank you very much, and stay tuned for more online webinars.
Thank you very much, guys. Take care. Yeah. Bye.